Well, good morning, everybody. So I've been asked to do a video on the integral of the square root of 16 minus x squared over 11x squared. Now, note the 11x squared is not in the radical. It is outside the radical. And in the problem, we get, or we are told in part of this that the correct substitution to use is 4 sine theta. Now, please note, I've done this a couple of different ways, so you can actually do 4 sine theta, you can do 4 cosine theta, and where the 4 comes from is the square root of 16, because we would like to eventually be able to factor that piece out. So we're looking at an expression that will read 1 minus sine squared, or 1 minus cosine squared. All right, so back to the details. So the 11 I pulled out in front. X is 4 sine theta, so dx is 4 cosine theta d theta. I replaced the dx with 4 cosine theta d theta, so the dx has been substituted out. I replaced the x in both instances with 4 sine theta and 4 sine theta. Now, over here, I will have 16 minus 16 sine squared theta and 16 sine squared theta. This 4 will move out into the front of the integral, so I will have 4 over 11. I'll have 16 minus 16 sine squared theta on the outside, or in the inside of the radical. On the outside will be cosine theta, and underneath will be 16 sine squared theta. This 4 and this 16 will reduce. We're going to factor out a 16. It's telling us to factor out a 16 out of these two. And what that will look like when we factor out the 16 is we'll have 16 and then in parentheses 1 minus sine squared, and we will convert that to cosine squared. When we reduce this 4 and this 16, we're going to have a 1. We're going to be left with a 4, so 4 times 11 gets us this 44. Now, ignore the typo. Notice I say typo. So this is going to become 16 square root of 16 times the square root of cosine squared. Remember, square roots split up over multiplication. They do not split up over addition or subtraction. And they will split up over division as well. So you have this 1 over 44. You have the square root of 16, which is 4. And that will divide into and reduce that down to 11. Square root of cosine squared is cosine. Cosine times cosine gets you cosine squared over sine squared. Now, in my head, I'm thinking, okay, I want to see something with cosecant coming out of this. So I started to look up some cosecant stuff. And I thought about the reduction rule for cosecant. So I'm going to have this over here. I've also thought about just straight up integrals with cosecant and secant. So these are just straight up integrals. These are typos from old work. I wrote down a weird reduction formula for cosecant here, but then I just wrote down this one, and I thought, this is probably our best one to use if we need it. So I travel back up over here, and I convert the cosine squared back to 1 minus sine squared. This is a common denominator, so I have 1 over sine squared, and just it's sine squared over sine squared, which is just 1. And I have the 1 over 11s in front on both of the integrands because I break the integrand up over the subtraction. That's allowed because the integrand is a symbol for summation, and summation and subtraction are basically the same idea. So I have 1 over 11 is equal to the integral of cosecant squared, because 1 over sine squared is cosecant squared, 1 over 11 theta. I didn't need the reduction formula, but if I did do the reduction formula and thinking about this as a 2, well, this is negative 1 over 2 minus 1, which is 1. Cosecant of 2 minus 2 is the cosecant of 0, or cosecant of, the exponent of 0. So that piece would become 1. So then I would just have the cotangent of x, and then 2 minus 2 is 0, so that falls off. So really, the reduction formula supports the idea that the integral of cosecant squared is negative cotangent theta, which is kind of cool. So this piece is theta, because when you take the integral of 1, you get whatever variable you're dealing with. And then plus c. So I have this negative 1 over 11 and this 1 over 11 negative cotangent theta. Now, remember we did this. We did the x is 4 sine theta. And when we solve for theta, because we're trying to figure out what that theta is, that angle is. Theta is sine inverse x over 4. Well, this builds our triangle. So I start my triangle, I identify my theta, opposite over hypotenuse, so it's x over 4. Use the Pythagorean theorem and we get the square root of 16 minus x squared here. Now, I'm going to take the cotangent of that angle, and cotangent is adjacent over opposite. So that's how I get the square root of 16 minus x squared all over x. And then minus, now theta is just sine inverse of x over 4. So that just happens to pop in right there. All right. So now I'm going to factor out my negative 1 over 11. I have the square root of 16 minus x squared all over x. The x is not inside the radical, plus sine inverse of x over 4, and then finally plus c. Hope that helps.